Alright, so in this video we begin section 4.1, which is also the beginning of the new chapter, chapter 4. So we begin by looking at linear functions and their properties and some applications. Alright, linear functions, well, they're really no different than linear equations. So the only new here is the function notation. All we do is replace the y with its corresponding f of x notation or our function notation. So, and again, let's recall that the number that multiplies x is the slope, which is also known as the average rate of change, and b is the y-intercept. Also, the new thing we're going to learn about linear functions is, well, when we have a positive slope, the linear function is increasing. When we have a negative slope, the linear function is decreasing. And if the slope of a linear of the line is 0, then the function is constant. So here is where we connect with the material from the previous chapter, in which we went over increasing, decreasing function that are increasing, decreasing, or constant at certain intervals. So in this case, we are going to determine whether the following linear functions are increasing, decreasing, or constant. Also identify the slope or the average rate of change and the y-intercept. So m equals 2 and b equals a -1, which in order pair is 0, -1. So we're going to determine whether this is increasing or decreasing. Well, look at the sign of the slope. It's positive, so it's increasing. To graph this function, well, there's many ways to graph these functions. You know, like plugging in values, that's one. Or the good thing is that we remember how to use the slope and the y-intercept as our references to graph linear functions. That'll save us a lot of work. For example, b is -1, and then from there the slope is rise to and run 1, rise to, run 1, rise to, run 1, and then just connect the dots. And as you can see, the line is increasing because it's going up. We're being read from left to right. All right. Again, keep in mind that m, the slope, is also the average rate of change. So when you do the homework and you do these exercises, you're going to ask you for the slope, but also the average rate of change. Let's do the next one. So we have s of t equals to -3/4 of t plus 4. Again, in this case, we're not using x and y's as our variables. We're using s and t, but the behavior is going to be the same. M equals to -3/4 and b equals 4, which in order pair notation 0, 4. And in this case, because the slope or the average rate of change is negative, in this case we have a decreasing function. Okay, decreasing linear function. Let's graph this using the slope and the y-intercept again. And we're going to go to the y-intercept first, which is in this case 0, 1, 2, 3, 4. And then from there, we are going to rise 3 units down and go forward 4. So 1, 2, 3, and 1, 2, 3, 4. So we are going to have a line like this. And as you can see from the picture, the line is going down. That is, it's decreasing. G of x equals 6, which is the same as 0x plus 6, if you will. So in this case, m, which is the slope, equals 0, and b equals 6, in which in order pair notation, 0, 6. In this case, we have m equals to 0, so it's neither decreasing nor increasing, so in this case, it's constant. It's a horizontal line at y equals 6. 1, 2, 3, 4, 5, 6. And this is what we have. Horizontal line. So the most important takeaway from this section, it's the building linear models and from verbal description. So in this case, we're going to apply this type of examples, these type of functions to applied concept typically in economics. Like for example, here we have the situation in which the functions that model the quantity supplied and the quantity demanded of hot dogs at a baseball game are given by these two functions, in which S is the supply, which depends on the price, and D, which means demand, and P is the price. So we have these two functions. So P is the price of the hot dog. Find the equilibrium price for the hot dogs at the baseball game, and what is the equilibrium quantity. What do we mean by equilibrium? So in this case, let's highlight this. So we are going to have the equilibrium price when demand and supply are the same. So we're going to find the value of P for which S and G are the same. Okay, so that's something important to know here. So we're going to start with S of P being equal to D of P. And all we do is write down the equations. So on the left hand side, we're going to write negative 2000 plus 3000 P equals to 10,000 minus 1,000 P. And we're going to solve this equation for P. So what I'm going to do first, I'm going to have all the P's on the left hand side. To do that, I'm going to add 1,000 P to both sides, which is going to cancel these two guys over here. And adding this up together, we get 4,000 P minus 2,000 equals 10,000. And then the next move is to subtract 2,000 from, or rather add 2,000 from both sides to cancel this, and this will leave us with 4,000 P equals 3, or this is actually 10,000. It's not 3, it's going to be 12,000. And then if we divide both sides by 4,000, then we get P equals 3, which in this case we use the dollar sign because we're talking about money. So that means the equilibrium price will be $3. So in the economic sense, this means that the supply and the demand will be exactly the same if the hot dogs are sold for $3. Okay, now what is the equilibrium quantity? To do that, all we do is plug this 3 in any of these two equations. So S of 3 equals negative 2,000 plus 3,000 times 3. And in this case, we are going to get the following: S of 3, which will be negative 2,000 plus 6,000. Wait, 9,000 So 9,000 minus 2,000, that's going to give us 7,000. So that's the equilibrium quantity. So selling hot dogs for $3 and 7,000 of them would be in equilibrium. Now, determine the prices for which the quantity demanded is less than the quantity supplied. So let's have a look at this. Well, quantity demanded, that is D of P, is less than S of P, the supplied quantity. So now we're going to solve an inequality. So 10,000 minus 1,000 P less than negative 2,000 plus 3,000 P. Okay, so first things we do, I'm going to have all the P's on the left hand side. And that's going to give me negative 4,000 P. Right, negative 4,000 P. And plus 10,000 less than negative 2,000. And then we are going to subtract 10,000 and negative 4,000 P is less than negative 12,000. Basically, we're doing the exact same operations that we did in the previous part. All right. And then divide both sides by negative 4,000. However, keep in mind that when we divide both sides or multiply both sides of an inequality by a negative number, we need to reverse the inequality sign. So P is greater than 3. Okay. So in this case, what is that? What does that mean in this case? So I mean, we solved an inequality, but what is the context behind all these calculations here? Well, they're asking us for the prices in which the quantity demanded is less than the quantity supplied. So we need to be careful with this, in other words, okay? Because if we sell this more than if we sell this for cheaper than $3, then there will be more quantity demanded than quality supplied. So if you don't have enough and you don't have enough supplies to meet the demand by the people buying hot dogs, which actually this answers letter C. What do you think will happen if the price of the dogs, if the price of the hot dogs, what will happen to the price of the hot dogs if the quantity demanded is less than the quantity supplied? So, well, in this case, you will have to lower the price. Because there's not too much demand, well, lower the price so you can increase the demand. So if people see the hot dogs cheaper, well, they're gonna go buy them. Okay, let's do another example and wrap up this short section. This problem has to do with depreciation, also very common in economics and incidentally in engineering as well, right? Because when someone works in the engineering area has to have an idea of how this type of situations work. So for example, a manufacturing facility has a new machine. So the new machine costs the cost was $120,000, and then the company chooses to depreciate the machine using a straight line method over 10 years. So that means after 10 years the price will be zero. It's going to be worthless. Okay, write a linear model that expresses the book value v of the machine as a function of its age. Okay, so in this case, what kind of information do we need to come up with a linear function? Again, keep in mind that we need the one point and the slope. However, we don't have the slope, and in a way we have the points. Okay, so we are going to define 2 points in this case. The first point will be denoted P1, which in this case is going to be 0, 120,000. What does that mean? It means that when the time was 0, that is, when the company got the machine as new, the value was $120,000. And then the P2 indicates that after 10 years, the value of the machine will be nothing, 0. So we can interpret these two as a couple of other pairs. Find the slope, m equals y2 minus y1 over x2 minus x1, which is also known as the average rate of change, if you will. So y2 minus y1, 0 minus 120,000 divided by 10 minus 0, which in this case is, the slope is negative 120,000 over 10, and to divide this, to simplify this, simply cancel one of the zeros. All right. So in this case, there's two ways you can get the equation of the line using the point-slope form. However, in this case, we're given the y-intercept. So how about we just use y equals mx plus b? Or in function notation, rather, f of x equals mx plus b. So in this case, the slope was negative 12,000. So times x, negative 12,000 x plus, keep in mind that when you have the y-intercept, this value, the y value is b. So plus 120,000. All right. So that's the linear model that will describe this situation right here. What is the implied domain for the function? Well, if we get very technical from the algebra point of view, well, we have a linear function. We don't have access in the denominator to restrict values like that, or we don't have radicals to set the radicand greater than 0, or weird things like that. So we could argue, well, this is a linear function. We can plug in any single number to our linear function because it doesn't have any asymptotes. It's a line. It doesn't have any holes. It doesn't have any restrictions. However, in the context of the situation, there is an implied. So the domain, because in this case x represents the number of years, which is the age. So in this case, the company chose to depreciate its value from the very beginning, which is the year equals 0 until 10 years. So that's the domain of this function, 0 to 10. Now, what is the book value of the machine after 8 years? All we have to do is evaluate the given function or plug in the number x equals 8. So plug in 8, and f of 8, if we simplify, if we use a graphing calculator to simplify this, our final answer will be $24,000. So see how using this linear function to depreciate the value of the machine. Initially, its value was $120,000. Now, after 8 years, it's worthless. It's pretty much worthless. It's now worth $24,000. Now, when will the machine have a book value of $72,000? In this case, they're asking for the year x in which f of x equals 72,000. So f of x equals negative 72,000, and then x plus 120,000. So what we do is plug in here, where instead of instead of f of x 72,000 and solve this equation. So I'm gonna subtract 120,000, and I'm gonna get negative 120, negative 12,000 x equals, let's see, what do we get when subtracting these two numbers? 72,000 minus 120,000, and I get negative 48,000. And then when we divide both sides by negative 12,000, I get x equals 4 years. So after 4 years, a machine that had a value of $120,000, it's going to be valued for $72,000. All right, so this is the end of this video, very short section. So I'll see you in the next video.